So the farmers in the northeast United States were trying to farm this, and this was in the days before steam power, gasoline engines. So they'd have to pull their plows through this stuff. You can eventually pull all this stuff out, and that's why back east you see all these walls made of rock. They took these rocks out of their farm fields and stacked them up. Here is a place that some of you may know. This is Long Island. It is completely made of this stuff, which means it's not solid bedrock or the solid rock of the earth. That's also a problem because remember Hurricane Sandy eats away at this stuff fairly easily. Not a great place to build, but well, people have done it. Here were moraines where the continental glacier from the last ice age advanced and just dropped off its material. Long Island is a, well, kind of a dump ground for glaciers. And now it's a very expensive place to live. At least parts of it, apparently. Ah, it's getting dark in here. Here's a drumlin. The continental glacier, covering a good portion of the northern part of the world, flowed across this, rounding off this hill. Here is the Green Bay lobe drumlin in Wisconsin. Notice he farms it in contours to prevent erosion. Good idea. Here's more glacial till and trees growing in it. This is kind of cool. Notice what's happening to the tree. Trees always grow up toward the light, which means this is an unstable slope. This slope, little by little, is creeping down because it is unconsolidated or unstratified material. This is kind of cool. This is a castle in Scotland, Edinburgh, I think it's called, which is a little bit weird because they don't spell it that way, but you just have to work with it. This is north, this is south. The Roches Montagnais, or the Goat Rocks, were formed this way. Ice came across, scraped away this material. This was very resistant material. This was soft material. And now we have a castle on top of it. This is the resistant material. Back here is softer material. Oops. And the resistant material protected the limestone. I will show you more about Roches Montagnais in just a while. Here's an excellent picture of Roches Montagnais. They're called sheep rocks. And this is where a glacier has scraped across here. Here are erratics, large rocks that have nothing to do with the underlying geology that has just been dropped by glaciers. Here is where glaciers have scraped into the rock. In this case, it's granite. And these rocks have just been scraped across here. Imagine fingers across an old chalkboard, something you probably can't relate to. This is an old farm type structure, and here are old outwash formations. When you have a big glacial lake and all of a sudden the water breaks the dam, it will outwash and create these ripples. This, by the way, was built long after that. Okay, there's a reason that Minnesota is called the land of 10,000 lakes. There's a reason we have the Finger Lakes. They're all moraine dam lakes and kettles. Whoops. Here is an erratic. I believe this is in Central Park. These are big grooves. I know this looks like the grooves, but these are the big grooves left behind in the rock in Central Park by glaciers that came through here a long time before New York was built. This is a false color image of Canada, where the continental glaciers used to be. All those dark things, those are kettle lakes left behind by the continental glacier during the last ice age. We're not making this stuff up. And again, in Central Park, here are striations left behind in the rocks. Here are striations. See these large scrapes? Again, imagine you laying down here, a mile of ice on top of you, and at the bottom of that ice, several ton boulders scraping across. That would hurt. This is Roches Montagnais, sheep rocks. From a distance, you might think these were sheep up there. And I forget where this is, but these are more striations left in the rock. Pretty incredible what nature can do. Now, from about 2 million to 20,000 years ago, Earth was very glaciated. Right now, we are in what's called an interglacial period. And if there were no humans, we would probably go back to a colder time. But as you will learn or have learned, we are changing the atmosphere significantly. Now, why does the Ice Age occur? Well, several reasons. The Earth's orbit varies slightly over a 100,000 year period, not a huge amount. It also has an axis tilt that varies over 41,000 years. It has an axis wobble every 23,000 years, and CO2 plays a role in that too. We are, however, changing the nature of CO2. CO2 typically varied between, what was it, 280 down to 220 parts per million. We are now taking CO2 up to 298 parts per million, I think was the last measurement that I can recall. Also, when land masses move around with tectonics, depending on the position of the land masses, they can block or accelerate ocean flow and redistribute heat. If you block distribution of heat by putting your continent in the way, that can lead to Ice Age 2. So there are all kinds of things coming together. How do we know a lot of this? Well, these cold guys in a very cold lab are looking at drill core samples from very old glaciers. Arctic or Antarctic, I do not know. I would suspect the Arctic. This is not a job I would like. And again, you can see layer year after year after year after year in there. And the old bubbles in there can tell us what the old atmosphere was like, because air bubbles can get trapped. I had to lay this to the side so we could see it, but these are colder temperatures this way. These are warmer temperatures this way. Here is 2 million years ago. Here is now. We went through a cold period, and right now we're going through a warming period. This graph stopped a long time ago. We are now exceeding anything in the last 2 million years, just so you have historical perspective in terms of our temperatures. They name these as glacial periods: interglacial, glacial, interglacial. You get the idea. What was it like during the last ice age? Well, here's where Santa Claus lives. Ice covered all this area. Not the black line, the lighter colored line. Notice the British Isles, all of Scandinavia, the northern part of Russia, almost all of Canada except in the mountains and Alaska, and down here into the United States. Remember those moraines I showed you in the previous map next to the Great Lakes? This explains it. Here's the extent during the last ice age, during Pleistocene times. And again, if you think back to the map I showed you at the very beginning, there's a lot less ice now. This is kind of cool. Formation of the Great Lakes. About 14,000 years ago, as these large continental glaciers were melting away, they left behind huge amounts of water. Now, because the ice was up here, the water couldn't drain to the north, so the ice eventually drained in what would become the Mississippi. As the ice melted away, well, it's like taking a fat man out of a rowboat. The land actually bounces up. Kind of crazy, but it happens. And when that happened, and the glaciers no longer blocked this direction, the water began to drain out this area and formed what is now the St. Lawrence River. If you've ever been to Chicago, you know that the Chicago River can actually be reversed and go into Lake Michigan or eventually into the Mississippi River. That's also crazy. Again, here are the extents of old moraines across the northern part of the United States and Canada. Here is the till that forms Long Island. Sorry, if you're from New York, Long Island. You've got a problem with that? This is something cool that happens. In the Mesabi Range in Michigan or Wisconsin, I forget where it is. There's a range up here that has iron ore in it. What's weird is we find pieces of rock containing iron ore all along here. How could that happen? Well, think of you pouring pancake batter up here, and the pancake batter, I can talk, runs out in all directions. Well, when it ran across this Mesabi Range containing the iron ore rocks got distributed along the moraines. And this is what happened. Glaciers coming along, distribute that. What's going on lately? Here's Greenland. 0 means the ice would be staying steady. On the red end, we'd be gaining ice. On the blue end, we're losing ice. Greenland, one of our last major continental or ice cap type glaciers, is predominantly losing ice. You'll see that in a film. That's a problem because if that melts and Antarctica melts, and it seems like those are going to be happening, perhaps not in your lifetime, but it's happening, this is what's going to happen. First, let's look at the coastline 18,000 years ago. This light blue is where the coastline was 18,000 years ago. Why? All the ice that was up here on the continents, well, that water came from the oceans. It actually lowered the oceans. Kind of crazy. So you could have bought a house out here. It would have been a little chilly. And you would be really young, like a negative 18,000 years old. Now the coastline is right here, and if we continue to be really good at melting ice, this is where the new coastline will be. People who say, hey, doing anything to stop rising CO2 levels is going to be expensive. Just think how expensive this is going to be. Yeah, it's not going to happen quickly, so we don't really need to care. You're right, never mind. That's it. Thanks for watching, folks. Let me figure out how to stop this.